Fine.
Good afternoon, everyone, and welcome to today's webinar on Geoinformatics application in civil engineering. Greetings from Department of Civil Engineering, Amity University, Haryana. It gives an immense pleasure to share a feeling of gratitude to introduce today's speaker, Professor Nageswara Rao. He is serving as consultant, Karnataka State Remote Sensing Application Center, that is called KSRSAC, as well as faculty member in BTU. Dr. Nageswara Rao got his BSc degree from Andhra University, MSc, MPhil and PhD from Vikram University. He joined the profession of remote sensing in the early 1978 at National Remote Sensing Agency. Now it is called ISRO NRSC. During his short period from 1980 September to February 1982, he served as a research officer at IIT Kharagpur. He joined the Indian Space Research Organization at its headquarters in Bangalore in February 1982 and served in various capacity and contributed significant towards establishment of National Natural Resource Management. He served as a member secretary of high-level committees in NNRMS in the sector of related to agriculture and water resource. As a member of many experts group committee, he has paid the way institutionalization of space technology-based service in this sector. He has served 5 years as a head of the Southern Region Remote Sensing Service of ISRO during 1982 to 2003 and served as a project director for many projects of ISRO. He joined in Northeast Space Application, Shillong in July 2003, and as director of the center, he has developed NESAC, that is called Northeastern Space Application, into Central of Excellency in the application of space science and technology in addressing the development needs of Northeastern region of our country. He was the program director of ISRO Geosphere Biosphere program during June 2011 to February 2013. He retired from ISRO as an outstanding scientist on 28 February 2013. He has more than 70 publications in peer-reviewed national and international journals and contributed chapters in few books. He guided many MTech students and 5 PhD students. He has been honored thrice with ISRO Team Excellence Award in the year of 2006, 2007 and 2008. He has been confirmed ISRO Merit Award in the year 2008. He received the prestigious Satish Dhawan Award for the year 2009 from Indian Society of Remote Sensing. With this introduction, now I would request Professor Nageswara Rao to deliver a talk on geoinformatics application in civil engineering. Thank you, sir.
My pleasure. Thank you very much, Dr. Naveen, for taking this initiative of considering me appropriate for participating in this webinar, and I hope you would all like to hear this lecture from me. And I have, of course, I have been speaking at several places in a webinar mode like this, but I hope I'm feeling very happy that you called me all the way from Amity University in Haryana. And it is my pleasure that I will be with you all for another 1.5 hours. Thank you very much. So let me share my PPT and then continue. Okay?
Yes, sir. Please go ahead, sir.
Sure. Yeah. All right. Take this. I hope all of you are able to see.
Yes, sir.
Okay, good. The topic given to me is geoinformatics applications in civil engineering. For those who have not seen me or who have not contacted me earlier, can see this, the email address. Are you able to see my pointer also?
Yes, sir.
Yeah, I hope so. Here is another laser I am using. Is it
Yes,
very clear now?
Yes, sir.
Okay. So this email, ppn1953@gmail.com, is easiest to remember. All of you can note this email and be in touch with me subsequent to this lecture, this webinar. So let me start with the the task that a civil engineer does. Civil engineering tasks involve developing and sustaining infrastructure. This is the critical job and the most crucial job that the civil engineers do in any part of the world. When you say infrastructure, an infrastructure project has always a life cycle. The life cycle starts with the planning and design, data collection, management, construction, operations management, and maintenance of an infrastructure project. So these are the different life cycle stages of a life cycle of a project. At every life cycle, at every stage of this life cycle of an infrastructure project, the geoinformatics has applications. You would really appreciate that part as we go into the subsequent part of the webinar. Now, the job chart, if you go into the details of a job chart of a civil engineer, he could be a structural engineer, busy with building dams, buildings, offshore, constructions and pipelines. He could be a transportation engineer, busy with road construction, railways, canal designs, and airports. He could be an hydraulics and irrigation expert, busy with canal alignment, preparing water supply networks, drainage networks, and flood barriers, etc. And if he is a maritime engineer, he would be busy doing ports, construction of ports, harbors, coastline protection, and geotechnical engineers, mining, earthquakes, earthworks, and construction foundations, etc. Designing the foundation and construction as a technical engineer, soil testing, some of those, and soil properties, some of those are important component of a geotechnical engineer. Then water resource management, the most crucial and very important part of a civil engineer's job is how to manage the surface water resources, exploit more groundwater resources, and conserve also, not only exploitation, conserving the groundwater resources and managing, agricultural droughts, etc., and flood management, etc. Some of those issues concern a water resources manager. Now, coming to environmental management, the most crucial and most important component before the project is ever approved, an engineering project is approved, environmental impact assessment and environmental management plan. This is, pre-project assigned task, and this is post-project task. And also assessing how much is the land degradation that is taking place, what is the water pollution. Some could be point source pollution, or sometimes something could be non-point source pollution, which is the other name for non-point source pollution, also can be called as eutrophication of the lakes, rivers, or bays, or some of the oceanic regions also get eutrophicated. Also, the last and not the least is the National Program on Disaster Management. In fact, we have from 2005 onwards, there is a National Disaster Management Authority and an act promulgated in which the use of technology is promoted, use of geospatial technology is promoted in a big way. And of course, when we talk of disaster management, at 3 stages: before the event, during the event, and after the event, after the disaster occurs, an civil engineer has a role to play. So we'll touch upon some of these areas and see what is that geoinformatics can do. Before that, I would like to explain to those of you who are amateurs in this subject, what is geoinformatics? Geoinformatics components include, there are several, 4 or 5 major components of geoinformatics. Among them, the first is the remote sensing. The shortest definition of the word remote sensing is sensing from a distance. This has got, sun is the source of energy for most of the, whole of Earth's surface. Without sun, there is no Earth and there is no life on Earth. So the radiation from sun passes through the atmosphere and clouds. Of course, in the micro region, active sensors penetrate through the clouds, and the radiance reaches the Earth's surface, and the targets on Earth's surface, depending on their physical and physicochemical properties, some of the radiance is reflected back, and some part of it is emitted back. It is this reflected and emitted radiance which is collected by the sensors, is directly transmitted to the Earth station, and the pre-processing of the data is done, and then it is further taken by analyzed distributed to analyze, and transformed into information for decision making. Also, there are other alternative methods. From this sensing satellite, it sends to a data transmission and relay satellite, and which in turn sends it back to the Earth station. We have this Earth station at Shamshabad near Shadnagar near the international airport at Hyderabad in Telangana. Present Telangana, we have that, and it is under the jurisdiction of National Remote Sensing Center of ISRO. This data is received from the satellites directly and processed and sent to distributed to users. Several lakhs of users take this data and analyze it and use it. So that way, sensing from distance is remote sensing. There are several satellites, Indian satellites, several of them, and of course they are either placed in polar orbit, moving from north to south or south to north, or equatorial orbit, geostationary orbit. These are remotely sensed data is a sort of these technologies. Remote sensing is also a sort of data collection, processing, and analysis system. If you appreciate the scientific functioning of this remote sensing, the word remote sensing also includes spatial data collection, processing, and analysis. And we have Cartosat 1, Cartosat 2, and ResourceSat 1 and 2, and several others, Megatropics, StatSat, Saral satellite. Oh my goodness, several of those satellites, even remote sensing satellites are being sent to Moon and Mars also. Chandrayaan 1 and 2 and Mangalyaan 1 also in a way remote sensing satellites. They sense from a distance those planetary orbits also, planets also, and the other satellites like natural satellites like moon of Earth, and other satellites, natural satellites of other planets also are being now studied using this technology of remote sensing. Now, what does this remote sensing do? In this shortest reply I can tell you is remote sensing provides answers to what exists where. This is the most important contribution that in a layman language I can tell you. Remote sensing gives you information on what exists where. For example, look at the this is a typical Bangalore image I am showing you. In fact, you have the Vidhan Saudha, Vikas Saudha being coming up, and at that time this is a little older building, and this is a multi-story building here, and the High Court of Karnataka building could be seen, and several trees and some trees in front of the Vidhan Saudha, and you can see them. This is a spatial resolution of the order of about, say, a few centimeters, about a meter and less than a meter spatial resolution. Here you have another image, some indoor stadium and then the other stadia in the sports club on the Residency Road you have. And here you can see the tree cover in black and white panchromatic image, road network, several vehicles here, you can see them. And of course, there are buildings. If you look at this, the density of the buildings, from the density of buildings and the number of occupants you guess, from this building, you can always say that what a dense building, a densely populated area it is. In other words, when you have a raw data, remotely sensed data coming from satellites or from aircrafts or drones, through image interpretation, digital image processing, and digital image classification, this raw data is translated into a decision-making tool and information in the form of maps and statistics generated for taking actions at an appropriate time and utilize that information for decision making. This is what the information retrieval process from remotely sensed data to answer the question, what is existing where? This is what the main job that remote sensing from a distance does. Now, when you talk of the second component of geoinformatics is GIS, Geographic Information Systems, for short name as GIS, it is a spatial data analysis tool. My definition of the word GIS, although there are textbook definitions and long definitions, the simplest definition I can tell you is GIS is a spatial data analysis tool, and it is also location science. GIS is called now the location science. It is a spatial data is always have a location information. And what this GIS does and what spatial data analysis does is when you have, you can put several layers of information, geology and rock types, geomorphology of a place, soil physics and soil properties, water resources, forest and wildlife sanctuaries, present land use, and population density. If you are putting all these multiple layers of information, and if you want to inquire what is this here, and also trying to find out answers to the questions like, at this place, what I'm showing you here, how much area, where, how many, which are they, what percentage in each village, and names of locations, and which route, etc. If these are the questions that you are trying to seek answers for decision making, in the case, suppose in the case of emergency, of where, how many, which route, etc. are the questions that you always ask during disaster management or when you are planning some project. So that way, GIS is a spatial data analytics tool, and the GIS enables, again, decision making. The GIS data, the spatial database in the geographic information system could be created in the form of raster data, or it could be in the form of points, lines, and polygons in the vector mode of database creation, spatial database creation in vector mode. And this is, of course, in the real world. Assume this to be a real world where you have a marshy land, you have a lake, you have a grassland and a dry fallow lands and a forest ecosystem. This natural world, what you see is a natural world, can be taken into a computer through a vector-based model or a raster-based model. The raster-based model of identifying location in the raster-based model is by grid cells. The XY coordinates, X and Y coordinates of the grid cells give us information on the location of a place. Whereas in this case, in the vector model, the location is identified by XY, and height of the target, what you are seeing on the images or on the ground, is represented by Z. Z represents the third dimension, the height information, and the simplest elements in the in the real world, for example, the location of a high school can be represented by points. And if you are trying to find out the road or a canal and a drainage, it is represented by lines. And if you are showing a sugarcane field or a few thousands of hectares of forest cover or wildlife sanctuary, you can show them by polygons. So that way, the spatial database is created in GIS in either in raster mode or a vector mode. So this is the details of which some other time when we are talking only exclusively on data modeling, we can discuss that. But I will skip for go to the next part of the component of geoinformatics. The third component of geoinformatics is the global navigation satellite system, called the GNSS for short. The GNSS, the other name for GNSS, which we have been using several decades now, is called GPS, Global Positioning System. The word GPS is a United States of America coined name, Global Positioning System. Similar GNSS are fully operational by Russia, called GLONASS. Europe is operating a system called Galileo. China is operating a system called BeiDou. All these are global navigational satellite systems. Whereas some countries like France, our country, India, Japan, have their own regional navigational satellite systems. Our Indian regional navigational satellite system is called NAVIC. Our beloved Prime Minister called this as NAVIC, and NAVIC stands for Navigation with Indian Constellation of Satellites. NAVIC is a nickname for NAVIC. The other name, popular name for NAVIC is an Indian GPS. NAVIC is India's name, and its full form of it is Navigation with Indian Constellation of Satellites. Well, this is the GPS constellation of 24 satellites in 6 orbits, 4 each is what is animated here. Whereas in the NAVIC configuration, we have 7 satellites, 4 of them in these orbits and 3 of them in geostationary orbit are functioning. And that way, NAVIC provides with with uncorrected 7.6 meters location accuracy for a region whole of India and 1,500 kilometers around India. Also, the NAVIC provides location information. Again, GPS also is a technology that strengthens the location intelligence, collection of location intelligence and location-based information, and navigation and positioning is possible with these global navigation satellite systems. It is not only position, location and position, also navigation. In fact, when you are sitting in a Uber car or a Ola car, he takes you to the destination using the navigation and positioning capabilities available from GNSS technologies. So that way, the use of GNSS, in other words, use of space technology and satellite positioning systems for navigation and positioning has become a routine day-to-day, fully operational, daily layman's usage it has become. Even those of you who have smartphone would know how easy it is now to identify a address of a place of your friend or your relatives to reach them because of the technology that is supporting the navigation and positioning. Now, these are some of those, details about the GPS. You have the space segment, you have the control segment, and you have the user segment. All of us who have smartphones with their GPS, we all form the GPS user segment. Billions of people now constitute the user segment of the global navigational satellite systems. Whereas NAVIC has 7 satellites, and GPS of USA has got 24 satellites fully operational in 6 orbits. And control segment, does the balancing and maintaining the spacecrafts in their orbits, and also liaising with the improving the accuracy of the user segment. There are several handheld receivers and used for location positioning and the location identification by XYZ coordinates. The fourth component of geoinformatics is the unmanned aerial vehicles, also called drones. This has become now very popular technology for several applications. Drones have become all pervading, and this technology is being now used for several applications, both in civil engineering, in disaster management, project monitoring, crop pest and disease control, several of the applications. In fact, what is needed here in using these drones is good knowledge of photogrammetry. Using the photographs for making measurements, height measurements, and volume estimation, etc., have become very popular now with these technologies. Drone-based remote sensing, I can tell you. There are powerful cameras. They are now giving these remotely sensed platforms are giving about 1 millimeter spatial resolution, and they have a duration of endurance of about 20 minutes mission, and they have a range of 2 kilometers from the place where you are standing. They can go up to 2 kilometers, take pictures and return back, and they have capability to easy data processing and 3D modeling softwares are now possible, and several corporate companies, even ISRO centers, for example, the Northeastern Space Applications Center at Shillong, where I was director for about 8 years. That center has got capability to build the drones, acquire data, then process data, and provide inputs for decision making and for several applications. They have end-to-end technology. Among several centers of ISRO, my center at Shillong, Northeastern Space Applications Center, has become one of the very few institutions in the country under the government setup to have a full-fledged end-to-end capability of providing services using unmanned aerial vehicles and remotely sensed data from those platforms. So sum it up, to put all those pieces of information, what so far has been discussed into a nutshell, this is what the geoinformatics would appear like. You have in this, overall configuration of geoinformatics, you have data collection systems, which are satellite remote sensing and drones, etc. Aircrafts also. These are data collection systems. Again, GPS, global positioning, global navigation and satellite systems, and the GPS receivers put together also becomes a sort of data collection system for the limited purpose of understanding the geoinformatics as a whole. So if these are data collection systems, then you have a data synthesis system, data analysis system. That is where you have database management on one side, the analysts on the other side, the human resource on the other side, and the computer algorithms, software coming from software teams, and the hardware that constitute the data processing and analysis component, and a set of algorithms, set of rules and procedures, all that form part of this overall analytical system. And that is this core of it is what we call it as GIS, Geographic Information System. Capture, entering, storage, processing, analysis, and display of the information. This is what these are the functions of GIS, Geographic Information System. Then, of course, you have the internet, all-pervading universal network of networks. Internet is the medium through which the information is disseminated. For example, the Bhuvan portal of ISRO's geospatial portal called Bhuvan, is the window through which all that what is synthesized and analyzed is disseminated to several users in the country. And of course, supporting technologies like photogrammetry, then geostatistics. For example, when you have point data and conventional data coming from other than the GNSS and remote sensing technologies, when you have point data, that point data, if you want to interpolate and make maps and polygons and maps, you need what you call geostatistics. Geostatistics or geospatial statistics is also a very important component of the so-called geoinformatics. And photogrammetry for making measurements from photo, determination of height, weight, volume, etc. Some of those things are possible with photogrammetry. The applications of this technology, what you receive from this whole system, is being now used for natural resource management, environmental management, infrastructure planning, urban and regional development, location-based services, and of course several end users, both in the private, public, and non-government systems. Several lakhs of people are using this information. When you say LBS, one simple example of location-based services, I can tell you, when you place an order sitting at your home for a big basket, when you are ordering for books from Amazon or Flipkart, these books or the goods are delivered to your doorstep where you wanted, and the location information is shared, and they deliver the goods right at your doorstep. One way you can call that as the commonest form of location-based services. Even the Uber and Ola taxi services that we enjoy these days at a reasonable cost of travel is also in a way called location-based services. So that way, this technology of geoinformatics is all pervading, and it is being used by several millions of people, and they are benefited by this, and several business opportunities, and what should I say? Several enterprises are being run on the using the geoinformatics as at the core of the technology driving their business and enterprise. So this is what the summary of geoinformatics, summary chart or synthesized chart of the geoinformatics. In fact, I should say that I can stop at this stage itself and ask for questions from participants. But should I proceed? I have several other slides to discuss on the applications of each of these. So far, what I have explained is only the what is geoinformatics, is what I have described, and I have several examples to discuss on each of these. I hope I can proceed. Or should I give a small break and seek any clarifications needed?
Yeah, sir. You please go ahead, sir. Please go ahead. Because we have 1 hour. Last 15 minutes, we'll have a discussion.
Fine, fine. I'll proceed. Thank you, Naveen. Thank you. Okay. Now, when you talk of spatial data analytics, there are geoinformatics analytics. I don't know why this label is sitting here. Yeah. When you talk of geospatial data analytics, what I mentioned in the previous slides, the data analytics could be, the geospatial data analytics could be a simple database query. It could be vector data query or a raster-based data query, or it could be spatial geospatial measurements in terms of measurement by density of people, or measurement by distance from one place to another place, or distance from, and also question of analyzing what exists in the neighborhood of a point of interest. Say, for example, if you have planning for a road, whether the road is bypassing a wildlife sanctuary or a temple or a holy place, etc., could be neighborhood analysis. Then you have overlay operations. When you talk of overlay operations, the overlay operations could be vector overlay operations. It could be point on polygon, line on polygon, or polygon on polygon, are the queries that you can make. And raster overlays, of course, you can put several layers of information, several dates of images of remotely sensed data from several satellites, and see change detection that is taking place over a place. Change in terms of land use change in terms of land degradation, or change in terms of deforestation, or change in terms of urban sprawl. All that can be done through several multi-date analysis of images that you acquire from remotely sensed data. When you talk of network analysis, networks could be finding out the network tracing, routing the network, and allocation of the network. When you talk about a railway network or a road network or a drainage network, you can always trace it, route it, and allocate the network. That is part of this spatial analysis. Surface analysis, when you talk of surface analysis, deriving contours, slope, aspect, and hillshade analysis and watershed analysis all form part of, these are very important component of a civil engineer's job in the context of water resource management. Well, as when you are planning to develop, build dams, or determine the storage capacity or height of a dam, all these parameters come into play. That is what is called surface analysis. Then geospatial statistics, geostatistics, spatial autocorrelation. What is the relationship between point to point? And for example, in the case of gold mine, what would be the gold content from place to place? What would be the variability of the iron content, or a pollution in the context of non-point source pollution? You can always find out what would be the quantity of toxic elements in the soil from place to place through correlation, autocorrelation, and interpolation techniques. Once you know a few samples of data, you can always interpolate that data with using that data already collected, and you can interpolate and find out the area likely to be affected by the phenomenon happening. The last one is the geovisualization. When you talk of geovisualization, it is one of the best and the final component of providing information for appropriate decision making. Classification, reclassification of data, and the 3D visualization of data is all possible as part of this geoinformatics. And this geospatial analysis, normally the geospatial data analytics subject, which I teach for about almost out of 48 hours, almost 24, 30 hours I discuss on this subject. In fact, my students of MTech students have a lot of interest in understanding the spatial data analytics. All these components form part of spatial data analytics. Now, let me take you to typical applications of relevance for civil engineering. Look at this, classical example of a civil engineering project. Etinhole, I'm sure you must have been hearing several things about the Etinhole project in Karnataka. This is a tributary. This is a small tributary, taking work in the Western Ghats and traveling. And, it is part of Sakleshpur Taluk of Hassan district. And it finally joins, this small tributary joins the Netravati in the western coast of Karnataka, passing through the Upinangadi in the Dakshin Kannada district of Karnataka. Ultimately joins the Arabian Sea at Mangaluru. This on this tributary called Ettinholli, small tributary of Netravati, the government of Karnataka is building a dam here, and they would like they propose to take large part of this water, some part of the water, to westward into drought-prone districts of Kolar, Chikballapur, and Chitradurga, some of those districts of Karnataka. So, in other words, this west flowing tributaries water is being taken into the eastern side of the state of Karnataka, so that the agricultural highland regions of these interior districts of Karnataka have the benefit of drinking water as well as irrigation facilities. But the questions remain when you go for approvals for a project like this, and when you are spending about 13,000 crores, nearly 13,000 crores of money, you need to go to the National Green Tribunal (NGT) with a detailed project report. DPRs are not accepted that easily unless you have a complete assessment of the social impact, you have a complete assessment of the environmental impact, and you have a post-project plan of action for environmental management. If these three components, along with the cost justification and the cost benefit to cost ratio, if it is not properly worked out, I'm sure no project will ever be approved by the central government, and it will not pass through the gates of NGT, National Green Tribunal. So it is in this context of addressing and generating appropriate information, accurate information, verifiable information that you need a technology like geospatial, geoinformatics technology. So, there are several questions posed for a small project like this. Does the lifeline of the Dakshin Kannada district, which is Netravati River, to eastern part of the state of Karnataka, does it deprive the lifeline of the people of Dakshin Kannada district? It's a big question mark several times that you hear in the newspapers, local newspapers in Karnataka. So to answer these questions, you must get appropriate data, appropriate maps, appropriate survey reports, and appropriate, justification for the project, answering all doubts that people, stakeholders raise, those who are in the project and outside the project area. Now, when you talk of the applications, another important area of application is regional planning and urban development is one of the important areas of applications of geoinformatics. When you talk of regional planning includes large commercial airports, harbors, industrial towns, recreational sites, need a lot of spatial data. Site investigations require topographic and geological information. Dam site selection require terrain information, most crucial. And river crossing sites and bridges and pipelines would always require information on stability of the slopes of river banks, terrace faces and valley walls, history of river erosion and sedimentation. When you talk of bridging when you are trying to build infrastructure, you also should know what is the soil physics and different soil and rock types underlying the proposed projects. A lot of geological information is needed for project execution and project development. And when you talk of hydrogeomorphological information, locating successful groundwater boreholes. When drought occurred during 2015, most serious drought in a large part of southern part of southern part of India, when the horticulture gardens were drying up, horticulture was under threat because of a serious drought. There was a need for sowing the successful boreholes which are 90 or 92% success when a farmer is advised to put a borehole. So success rate of a borehole must be high before suggesting location for exploiting the groundwater for saving the horticulture gardens. Also, when you talk of network management, the word network management covers electricity supply lines, road, railway lines, drainage networks, and irrigation canals management all come under the purview of network management, which are also the jobs that civil engineers perform. Now, I'll take you a few illustrations of what I have explained. For example, if someone is trying to get the site selection, or someone trying to understand the hydrogeomorphological or geological information of a place, you need to know, for example, what are the landforms and what is the geomorphology and the landforms. You can derive landforms from a topographical map also. The contours are available. You can infer some height information, etc. But satellite images also provide additional information than what you get from a topo sheet, which is around 3.5, 4 decade old topographical maps. You can always use a current latest satellite image, even if it is a true color image like this. And for example, here A is a denotational hill. This whole part is a denotational hill, and B is a sort of pediplain. Here you see a pedimentous zone just at the foothills of the hill is a pediment, and further far from pediment, you can always see a sort of pediplain is easily identified. Then you have valley fills, D, labeled as D here. The valley fills, you can always find out these landforms. These landforms can provide you a lot of information. Once you know the properly identify these, landforms, you can always assign what is it. You can always guess what is the rock type at the bottom, what is the soil type, the thickness of the soil, and then what would be the groundwater prospects. For example, in a valley fill like this, the groundwater prospects are always very high compared to a Piedmont or a pediplain. So that way, you can always infer from an interpretation of these images. Of course, you need an appropriate background to interpret these images. One has to be a geomorphologist or a geologist with a little knowledge of soil science. One can always also the landforms, how the landforms are developing, the developmental process, genesis of landforms also play an important role in judging what is below. For example, when you are trying to find out where to put a bridge on a river like Brahmaputra, which is highly, migratory type, and which is a very largest river ever you can think of in India, where to put a bridge or a connecting road from the southern bank of the river to the northern bank of the river. Where should we put a bridge? Is a job what was given to us way back in 2004 timeframe when I was director of Northeastern Space Center. A bridge to be put on Brahmaputra River. So what we did was we took 1966 images, 1990, 2000, 2004 images, and found out where the banks are more stable on this of this river, which banks where the erosion and accretion and degradation of the river banks are more stable. There we have identified and given the advice. This is a consultancy job we did for Consulting Engineer Services India Limited in Guwahati. We did this job when I was director of Northeastern Space Center at Shillong. So this, you can see that this is NESAC product developed by us. So that way, the location of appropriate location for the bridge on the river Brahmaputra was given by us. This is now built, and the north-south are connected. The northern part of the road and the southern part of the road are now connected at this point, which was found out to be more stable. Similarly, when you have geomorphic information, for example, look at this. This is a drainage called dendritic drainage derived from remotely sensed data, interpreted from satellite images. And you have trellis drainage pattern, you have rectangular drainage pattern, angular drainage pattern, and radial, annular, parallel, and centripetal drainage patterns. So each of these drainage patterns, what are inferred and identified and marked on the satellite images in the form of a, through basic photo interpretation techniques, you can always relate wherever you find a dendritic drainage like this, you can infer that the underlying rock below is always a horizontally bedded sedimentary rock and granites. When you have a dendrite, trellis type of drainage system, you can always infer these are folded sedimentary rocks. Then you have rectangular. This indicates these are flat-lying, massive sandstone formations. When you have an angular or radial drainage pattern, you can infer them to be volcanic and domes. And when you have centripetal, it is a clear indication that there are several sinkholes here, and the rock type below could be sandstone, limestone, and volcanic craters. So, in other words, what you are seeing is surface drainage network, but what you infer is the rock type below. The rock type and the nature of rock and the type of geology, what is underlying is what you infer. So this is one of the, I personally feel one of the best contribution from geoinformatics to a civil engineer to infer what is below what you can't see. You infer from these drainage patterns. That is the best contribution that can come from.
Sir, last 5 minutes.
Sorry.
Last 5 minutes.
Oh, we can't go beyond that.
No, 3:30 we should. Before that we have some discussion.
Okay, last 5 minutes. Okay, no problem. We'll try to do justice. See, for example, here you have two satellite images, one of limestone formation below, another of sandstone and shale formation below. So you can see a lot of drainage patterns seen here, whereas such a drainage pattern is not seen here. This is a simplest example that I can ever show before you of how valuable this remotely sensed data, which is part of geoinformatics. I'll skip some of these. Then I'll take you to terrain mapping and analysis. For example, digital terrain models, DTMs, they provide a lot of valuable information for deciding alternative alignment of canals, roads, pipelines, and corridors. Then the hydrograph parameters, these DTM provides, digital terrain models also provide very valuable information on generating and estimating the peak runoff in terms of cubic meters per second would always be generated if you have an appropriate DTM, digital terrain model. Information on soils, as I said in the previous slides, information on landforms and soil classes, and then construction material, where it is available, what type of construction material available, you can always identify through these image interpretation analysis techniques. Now, when you talk of DSM and DTM and DM, DEM is a raster model towards achieving a digital terrain model. DEM is digital elevation model. The approaches to generate a DTM could be a raster approach or a vector approach. The raster approach is called digital elevation model. The vector approach is called thin triangulated irregular network. Now, when you talk of height of a tree, you want to find out if you have a DSM and if you subtract the DTM from DSM, you get height of a particular target. It could be a building, or it could be a tower, or it could be a tree, or an electrical poles. DSM minus DTM gives you height information. There is a lot more to discuss on this. I'll skip some of this detailed information on that, and I'll take you to these are the approaches for creation of DTM. Several approaches for DTM creation. The DEM mode, and this is the DEM mode of creating a DTM. And you have the chin-based triangulated irregular network based DTM, digital terrain model is the approach, the methodology of which we can discuss later on. Of course, DTM also gives you a lot of valuable information, derived products from DEM. Slope, you can derive it. You can aspect, you can derive it. hill shading, you can derive it from if you have a raw dam digital elevation model. Then each of these slopes, aspect, and hillshade provide very valuable information in water resource management, in planning the canals, and several of those engineering applications of civil engineering applications. Terrain evaluation is possible using geoinformatics for the purpose of understanding the landslide prone areas where landslides are vulnerability to landslides. You can always find out in the corridor what you have decided, how many villages, how much acreage is to be acquired, how much compensation to be provided in the corridor of your road or a railway line or a pipeline. You can always find out. Water resource engineering, interbasin transfer of surplus flood flows, loss of storage capacity, assessment of command areas and crop condition in the command areas of irrigation projects, flood management, and lot of information on snow cover and snow melt runoff from inaccessible terrain can be derived from geoinformatics. For example, the entire Krishna basin, what is happening in the entire Krishna basin, you can always find out in terms of land use change, land cover change, etc. We found out what was once upon a time a grassland cover of 15.43% of this Krishna basin has now reduced to only less than 2%. Imagine what is the change that is taking place in terms of grass cover and for gomalams and grasslands, because of which flooding in the Krishna basin has become very popular, very common now, unfortunately. Also, you can see here the storage capacity of the reservoir from the area capacity curves. You see the change in area with time, and there are always area capacity relationships. Area versus capacity relationships are well known. Once you know the storage capacity of reservoir, how much of this stored water could be used for irrigating the command area, how many irrigation schedules can be decided, can be calculated based on storage capacity and the area under irrigated crops. This is a beautiful example in Tungabhadra and Krishna Sagar command areas of Karnataka. Also, you have town planning and urban development, systematic mapping and periodic monitoring of urban land use, transportation network also could be optimally utilized if you have geoinformatics-based spatial database created and use it appropriately for decision making. For example, our friend Ramchandran from Indian Institute of Science has done a good piece of work of tracing the urban sprawl of Bangalore city, and based on that, you can always, once you know the growth vectors, the direction and magnitude of urban sprawl, once you know, you can appropriately plan your urban development. We have given ring road alignment both for Bangalore and Hyderabad and Nagpur also. Some of the examples I have here. When we get more time, we'll discuss on this. Then this is urban sprawl in the Kohima town in Nagaland, which we did. And here is a beautiful example of stormwater drain management of Bangalore city, based on the carrying capacity of the present storms. We have given a proposal for excavating and cleaning the drainage channels for the BWSSB, Bangalore Water Supply and Sewerage Board. We gave advice from ISRO's regional center of ISRO. There are critical infrastructure protection for, particularly in emergency management. The geographical systems could be used for, finding out hazardous prone areas, risk assessment, vulnerability, all that can be done for emergency management. Even in case of COVID-19 management, our center, Karnataka State Remote Sensing Application Center, is providing very valuable information on primary contacts, secondary contacts, the containment zones, and the peripheral area of the containment zones, how much area one should allow and where not to go, what are the restrictions that are posed by the government. All that form part of Karnataka GIS, Geographical System developed by Karnataka Remote Sensing Application Center. Several inputs could also be given. Yeah, we can stop it here.
Yes, sir. Yes, sir. Just
Okay.
you can.
Yeah, I'm more or less through. This is something on groundwater prospecting. You can prepare the maps and even provide at what depth, at what yield of the groundwater potential could be always mapped and shown using the geoinformatics. Remote sensing for data collection and GIS for analytics and overlay operations, etc. You can provide it groundwater prospecting maps along with yield levels and depth of the boreholes that you can dig, also provided. Then in the context of recharging the groundwater prospects, where to put a nala band, where to put boulder checks for soil conservation, where to put a check dam, where to put a desilting tank, where is it located, where are percolation tanks, where are recharge pits, and which type of checks could be constructed in a watershed so that there is conservation of soil and water, and an appropriate land use plan can be suggested, taking watershed, a micro watershed as a area for planning and development. So that also we have demonstrated. Several lakhs of hectares of watershed development is done under the Sujala project, Sujala 1, Sujala 2, and Sujala 3 of Government of Karnataka programs. So the criteria for suggesting a check dam, percolation tank, invert well and recharge well, desalting tanks and recharge pits, where to put where, etc. has been discussed. Thank you very much for the time given for me.
Thank you, Professor. It is a wonderful and informative presentation. You have categorically discussed about various types of satellites and their application in civil engineering. And also you have highlighted the importance and applications of drones. In addition, you have discussed about geospatial analysis in detail. You have given a good case study of Ethinole project by highlighting the geoinformatic application in civil engineering. And finally, you are touching the drainage pattern of rock types and other case studies. Now, I am sure our participants have benefited by attending this webinar. Now it is time for the discussion. I request all participants to ask any questions if they have through the chat list.
Yeah, I'm ready.
Yes. Let's see. We have only last 3 minutes. That's right.
No problem.
I think we have your email ID and phone number. In case we got any questions, I will be sharing to you, sir.
Most welcome. It would be my pleasure to have feedback.
Yes, sir. Yes, sir. Okay, now because we have a lack of time, last 2 minutes, I should wind up the session now. I'm thankful to all my students, faculty, and staff for coming to attend this webinar. And also I thank our Director, Professor S. Sridhara, for providing us with all possible logistic support towards organizing this event. And also I sincerely thanks to Professor Nageswara Rao for accepting our invitation to be a guest of speaker for this webinar. And also I thank Mr. Ankit Batra, Shakshi Gupta, and Sanjeev for his support for organizing this seminar. At the end, I once again heartily thanks to faculty, staff member, and students for their support and making this program successful. Thank you one and all. And also I request all participants to fill the feedback. Before leaving the session, I sincerely request you please fill the feedback.
Okay, see you then.
Yes. Thank you, sir. Thanks a lot, sir. Yeah. Just we have 1 more minute. Let it, sir. Because this time is for the participants to fill the feedback.
No problem.
Sir, Professor T.V. Ramachandra is my PhD supervisor also.
Oh, nice to know that.
Yes, we have one good publication.
Wow.
Waste management.
Oh, very good. Very good.
3 impact factor journal we have published.
Oh, good. Nice to know that. I keep meeting and talking to him many times. We keep meeting at the seminars,
Yes, sir.
and in meetings, official meetings, when Government of Karnataka invites me, he also joins. There were several instances where Chief Secretary called for meetings, and I used to participate in those meetings. That was when Arvind Yadav was the CS. When there was serious droughts happening in Karnataka, way back in 2015-16 time frame.
Yeah. Whenever I go to Bangalore, I used to meet him.
You can meet me also. You can visit us.
Definitely. Yeah. Shortly, I will be meeting.
Bye.
Thank you, sir. Once again, thanks for accepting our invitation. Thank you, sir. Thanks a lot. Now you can leave the session, sir. Thank you, sir.
Sure. I'm doing that.